Starting. Yeah, live room. Just going to do some of my draft kind of stuff. Try to, draw stuff, and then I'll start show it to the camera, I guess. Turn off the window. Anyway, no, that was the wrong icon. This one is the one I want. I don't want that at all. Okay. All right. So, yeah, so I'm just going to go through some stuff on equilibrium. And I had another keyword somewhere. Wrote it down here somewhere, right? Yeah. Space-time. No, that's not it. Yeah, I had a better word for what I was looking for. Must have wrote down on this piece of paper somewhere. Dampening, maybe that's it. But yeah, it's just this whole idea of what gets collected and how it gets collected. So again, the initial theory is, that you just have all this background radiation. And it's all made of this idea of a photon, of a ton, a quanta, moving the speed of light in a straight line. And so this stuff, whether big bangs or not, it doesn't matter. The point is that we have this field of pressure. So we have a field of this stuff where there's an equal amount. It doesn't have to be an equal amount, theoretically, because everything in the universe could be moving left 50 miles an hour, and it really wouldn't affect anything that we would notice. So the field doesn't have to be balanced in that sense, but it has to have one giant irregularity that we can't see, or else if there's any little irregularities, they would be noticeable. So there can't be any inconsistencies in the local fields. But anyway, so even just describing the field, it's very simple, but it just gets complicated, right? Because the idea is just you're saying you have this random, you take a bunch of little BBs, you give them energy, you throw them into a container, and the idea is they'll eventually create an equilibrium if you have a sphere or something. And there'll be as many going this way as there are that way, as there are that way, as there are that way. That's the point. And so everything in that field will be experiencing the pressure of just as many encounters with things hitting it on its head as, trying to go up its ass, as left, as right, as front, as back. So it's this three-dimension thing and this pressure in those three dimensions. And that's basically what's creating planets. The idea of gravity is just that there's a tendency for things to get accelerated, because from every point from which they're not shadowed by something, they're all getting hit in an arc, and they're getting pushed towards, they're moving towards, because of the absorbed acceleration. So again, I have to use this qualified language, towards the object that's shadowing them. And so as soon as something becomes within the proximity of something else, a quanta is in the proximity of a quanta, technically, they will end up being encouraged to interact. And it's this not combining but interacting thing that creates an orbit. So, all right, so what I want to get to is there's a mechanism in this, and it would be really easy just to turn into those little balls and just say the little balls are banging into things and them getting pushed, but it's just not as simple as push, in the sense that the force is not, it's never destroyed. It's just converted. And so we think of energy as something getting used, but it doesn't get used. It gets recycled. It's getting to that mechanism of that recycling, and that the key factor is that the forces, which are the little bits, anything little bitish, anything a quantum moving the speed of light, that's all force, and anything with an orbit, that's all matter. And the two things don't function the same way. The forces
Could be a new post.
can't. That's so ironic. I mean, nobody's posted anything. It's only when I make a video, you know, somebody posts something. It's just funny. So whatever. No need to turn the sound off for that. It shouldn't be too incessant. I can always turn it off. Probably. It's probably going to show up on the other computer. So you'll hear it again when it finds out that there's an update. Anyway, live camera site, blah, 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 blah. Links somewhere, go find them. Anyway. Right, so I'm going to attempt to, for my own purpose, you know, I have to go through this anyway. So I've just been playing with the idea of what happens when there's an interaction with matter and, say, light or a mirror. And I've argued previously that it hadn't occurred to me, but that when you see a reflection, like in a mirror, what you're really seeing is a successful absorption of the energy. So the light was successfully absorbed, and the fact that you're getting something back is sort of an indication that the velocity going forward, the photon having momentum in, was eaten, and you're getting back this opposite thing. The getting back the opposite thing is sort of evidence that the thing going the right way made it. It was accepted, and now it's produced the equal counterpart. But in a way, I guess that could be argued that that's evidence of something going through something, in the sense that if it successfully goes through something, thinking, yeah, no, there would be no reason for it to send anything back, right? So if there's no absorption, there's no new fish going into the school. The school doesn't have to release any other fish. And you could logically deduce that, let's say if a fish, okay, so I got a school of fish, and it's balanced. And so I put a new fish in going that way. Now, if I release a fish, the school, so the school now has to release a fish. Now, if it releases it perpendicular, we would recognize that as magnetism or EMF. But let's just deal with the front and back. If it releases a fish going forward, well, then it obviously didn't absorb the velocity for very long, because what has to happen for it to release the fish going forward is that if it gained any, you know, by having the extra fish, it's now got more fish going this way than going the opposite way. So therefore, it moves. The school moves. Well, as soon as it lets go of that fish, well, then it's not going to have that extra fish anymore, so it can't move. Now, if it releases a fish going in the opposite direction, that means it kept the fish going this way. That means it's moving. So you could argue that the mirror, when it's absorbing, is the surface of the mirror, which could be argued is not the surface, right? Because the reflection is really happening behind the mirror, all right, after the glass, you could argue. So the glass, let's just say, is irrelevant, and that the silver is what really is reflecting, and the glass is just protecting the silver from oxidation. So it's this layer of silver that's doing the real absorbing. And silver, as an example, would be capable of producing EMF. So that's capable of producing field energy in the perpendicular directions. So it But the point is that we don't see the mirror move much. Even if you shine a laser, 5 watts are flying into that laser, that mirror. You would think that a very small laser would move a lot, and maybe even somebody's done experiments like this, but I don't know. You could take like a foil or a real thin film and shine a laser on it, and maybe you can get it to move a little bit. If you have a low enough mass, maybe you can see the light move the metal, the film. But I'm not going to argue whether that's possible or not. I think it's more likely that you are creating this EMF, that you're creating a field energy in the perpendicular in that case. But the point is what you're not creating is a bunch of energy coming out the back of the mirror. So it seems clear that the velocity in one direction was absorbed. You released a fish going the opposite direction, which indicates now you're plus 1 fish, so you do now have velocity. And so there has to be, for that, obviously that velocity is somehow getting lost. Somehow the velocity is not maintained because the film doesn't move. So we know those fish don't stay going. We know those electrons don't stay. They don't keep that acceleration. The velocity they gained through absorbing that photon, we know they give it up somewhere, because it's not moving. And so it's that process of giving it up that's the tricky part, because they have to give it up they have to convert it into some other thing, not light. It gave back light. So we could say that in the end, that's the conversion. It absorbed energy going one way, it gave back energy going another way, and that's the trick of matter, is that it's sort of like the idea of a spaceship going into the orbit of a planet and then looping around and going the opposite direction, and there's no loss in the system. So it converted its direction, its velocity from this to this without any apparent that was the real, it seems a perfect conversion. No waste. They don't lose velocity. Nothing seems to change except the things going a different direction. So there's something as a mechanism similar to that inside this matter, but it's trying to figure out exactly how to. See, the real point is, what I'm trying to say in all of this is that you can't really stop the fish. So anything going, any quanta going this way is going to keep going that way. And the only thing that really changes, like the light goes through the mirror is what I'm saying. The actual photons go right through the mirror. The actual quanta that make up the photon go through the mirror. And what's really happening is the frequency is stripped, but more importantly, the polarization is stripped. And so what leaves the mirror is like gravity. It is gravity. And what has happened is the polarization is being reassigned. And so now the polarization can be assigned to something going in an opposite direction. So it's almost like you could think of it as rails, like a constant stream of a, I'm trying to think like a streetcar rail or something, the cord that the car grabs onto. You have a cord going left, and left to right, and you have a cord going right to left. And it's as if, one is blue and one is red. And what really happens inside of matter is that the red is turned blue and the blue is turned red, and so they switch their colors. And so now you have this conversion where it started with the red cable on the left going in, and after the conversion you have the red cable on the right coming out. And so the cables are still moving the same direction. It's just the color has been shifted, but the color is how you identified the thing. You threw a photon at the mirror is giving you back a photon, but it's really giving you back a different quanta that's been labeled with the same frequency and polarization as the quanta that went in. And obviously sometimes it doesn't give you back the same frequency, because of filtering and different things. You can change the frequency of the light you get back using different materials and heating it and doing different things. You can put light of one color in and get light of a different color out, theoretically. Well, I'm sure there's experiments that do that. But anyway, okay, so that's the problem I'm dealing with, is in the sense that in the field, none of this stuff can happen. Polarization is transferred through every interaction. There's no bouncing. Nothing bounces off of anything else. So that's why fields can't interfere with fields. That's why gravitational lensing is a misinterpretation of data. It doesn't exist. I think that argument can be made, just because I think the evidence is incredibly weak for any decisive conclusions on bending light with gravity. But there's just no real world examples. It doesn't matter how big a magnet I make, I'm not going to bend a photon. It's just not going to happen. And I'm not going to be able to disable a magnetic field, or I'm not going to be able to, in any practical way. You just can't affect fields. You can only affect matter. So fields only interact with matter in the sense that the field is converted. So energy of one form is converted, and what we're really talking about is polarization. So energy really isn't energy. Energy is polarization. Our energy is frequency. Even though those sound like things that aren't important, those are the things that are really create the possibility for us to see a conversion. And it's the conversion that makes the distinction between me and the material around me. Is not only a density argument, but I would argue that the density is an illusion, that all of space has the same density of quanta, and that all that really is different between the space here and the space there, the space in my body and the space of the air around me, is the polarization of the stuff that has been captured in what we call matter, but is just really this field energy trapped in these, I like to say orbits, but I don't think that's entirely correct. The orbits are the patterns of the orbitals. The orbits are in the pieces of the atomic structure, not necessarily in the atom itself. So the atom, I don't think, is really doing much moving. The thing that's moving are the stuff inside. So it's the spin of the electron that people have interpreted as the rotation of the electron, something like that, more or less. And because matter does have a certain rigidity about it that I don't think is, I don't think the standard model works as an explanation, because matter seems so much more stable. And I think the stability is in the idea of magnetic relationships. So you can sort of understand that magnets don't do a lot of orbiting. They do positions. So if I have a bunch of magnets of the same, if I could put these magnets all flat on a piece of paper and they wouldn't flip over, I could obviously arrange them so they were all repelling each other. And I could put them in a configuration, and if they never flipped, I could tilt that configuration into the air, and I could just basically, it's only because they flip that you have a problem. So if I put them between two pieces of glass so they can't flip, you'd see that they can't interact with each other. They can't combine, but they can be pushed by more fields around them into a position, and they'll just stay floating in that position. So I could have two pieces of glass, put the magnets in between the two pieces of glass, and I could have a magnet just stay in between two fields, and it'll just stay there. It's trapped, and it's because it can't flip. It will stay there, and it'll do the anti-gravity. It'll do the levitation thing. It's just that it'll do the levitation thing because it can't flip. What defeats levitating devices is because in most circumstances the thing can flip, and it's the flipping that ruins the fun. Prevents you from visual seeing the levitation. The levitation isn't durable because any slight vibration in the field gives the magnet an opportunity to tip. A tiny bit of momentum will become consuming. It'll cause a chain reaction, so to speak, that will create the velocity necessary, the acceleration necessary to turn. The conversion of the field energy. So again, the field energy is what's going to be flipping it. And it's going to be the process of converting that field energy that will flip it. All right, so man, that's a lot of words. So what I want to do is just get to some kind of block diagram. So we know that there's an in and an out. So I guess that's what I'm saying here. So that we know something goes in and we know something comes out. So we have whenever we have a reaction between fields and matter, you know that that's what's going on. There's stuff flowing through the matter. And some of the stuff we can identify and some of the stuff we can't. Some of it's visible, some of it's invisible. And some of the invisible stuff will now be labeled visible, and some of the visible stuff will be now turned invisible. So there'll be a conversion of something we can measure into the stuff we can't measure, and the stuff that we can't measure will be converted into stuff we can measure, kind of a thing. We can measure all of it. It's just that you can't measure. Gravity is really hard to measure because you have to use matter to measure it. That's the key to this conversion thing, right? You can't see a field with a field. You can't bounce photons off of field energy. You can't in any way detect a field using field energy. So you always have to use a piece of matter, a nuclear bit, something electron or bigger, quark or bigger. I don't even want to mess with things that don't really. We know the electrons are durable. We know the quarks aren't. So the sensible thing to do is talk about the parts that are durable parts, not indurable, I think. Well, at least I'm going to do that. And they also fit in terms of we understand there's a definite relationship between the field energy created by the electron and the field energy created by the proton. We know they are, one could argue, I guess I would argue, that likes repulse, not attract. Well, like spins. If I spin this way and I spin this the same way, they're both spinning clockwise. It creates a conflict. The two things hit each other, which means they'll consume each other. They can bite into each other. But if they're If I spin one counterclockwise and one clockwise, then the two spins are, you can sort of see that there's no way to combine them. They can't bite into each other. So they just keep bouncing off of each other. But that's really not the argument I want to make. That's not the core of the thing producing well, it might be what is producing the polarization of the fields. So polarization just might be an orientation in three-dimensional geometry. And it's really hard to draw three-dimensional pictures on two-dimensional paper. But anyway, I don't know if it, I think for the purpose of understanding, you could probably make the mistake of either identifying polarization as a independent feature or polarization as a consequence of the three-dimensional geometry. That is the direction something's going in three dimensions. Okay, relative to something it's going to interact with. Yeah. Yeah. Probably good enough. So there might be something about the geometry that is the thing causing the conversion. So the field energy won't interact with field energy in the sense the interactions do not produce a change, blue cable to red cable. That doesn't happen. And somehow it does happen with matter. And the argument is it's the same forces are in the matter, the same quantum moving the speed of light. And there's a rule that exists for a reason. There's a cause why in the configuration that is matter, that field energy does allow for the conversion from blue cable to red cable. Yeah, that's what I want to get to. All right. So I've done all this talking. I haven't done much drawing. So I'm just going to basically be doing something simple like square and then arrows going in. So I'll just, for the sake of understanding, I'll just identify the arrows as red or black. And that'll be different polarizations. And for frequency, I guess I can just use multiple arrows, I suppose, or I'll have to think of some way to duplicate that, I suppose. Just make the arrow double or something. And then try to explain the conversion in the sense that, again, we know the mirror. We know the light goes in. We know we're getting back the opposite reaction, which means something had to be accelerated. Something went forward because we got back something. There was a conversion. And so there has to be there's still the forward velocity to account for. The fish going forward. We got a fish going backward. Now we have to understand what happened to the fish going forward. I mean, if it went in, something had to come out. But again, in the big picture, two fish went in. At the same time, the fish that we see, I mean, the photon we shot into the mirror, well, at the same time, a fish were coming in the back of the mirror, called gravity. The thing we call a photon light is really just gravity labeled with a polarized frequency. So technically, it's not something new. It's something that's just been labeled. So technically, when the photon went in, it's just the same gravity that's still coming from the other side. So there's still a proportional amount of gravity on the opposite side that's going to be pushing the thing back. So we're not changing the gravity equation. But what we are changing is the polarization equation. And that's, again, the argument. If we get the polarization back this way, something has to be going that way. But we have the example of the moon, where I can shoot the probe at the moon, get caught in the moon's gravity, and get slingshotted back. What happens to the moon when that happens? I mean, we know the spaceship doesn't lose any velocity, and it's converted. But does the moon lose something? That's the question. And I believe it does. It loses some of its velocity. We slow it down. Yeah, I think. Well, anyway, like I said before, this is all just conversions of energy. It's not creations and destructions of energy. So you're not really using anything up. So I just have to explain what went out and where it went. Yeah, so technically a reflection could be a reflection in the sense that the fish you're getting back is in the opposite direction. But what really changed was just a switching of polarization, and you can do that for free. Matter can do it for free. Doesn't require anything extra for it to do that conversion. Yeah, well, I guess I would still argue that reflection does require that EMF thing to happen. There has to be heat, or there has to be some other example of yeah, I'm just not sure. I mean, in an ideal world, I think the fact that we do see, like say if we shine photons on metals, that's Einstein's experiment, and we get the electromagnetic effect or the electro effect, and it creates charge. So the photon is, the question would be, are the photons that create the charge being reflected, or are they being absorbed? So those are the absorbed ones where there's no reflection. And clearly, the photons, we don't see them come out the other side of the metal. So if they're absorbed by the metal, which seems obvious that all of things related to the photoelectric effect are usually black, like solar panels, they're not reflecting the photons. So obviously they're not creating the electromagnetic, they're not creating the electrical effect when they reflect. Yeah. So, yeah, it just still seems intuitively sensible that if you're having the opposite reaction, if you're letting a fish go in the opposite direction, that's what it looks like. You're getting this photon coming back at you. That you're still 1 + 1 fish going forward. But again, it's just the overall field. There was no plus and minus fish. There was never an extra photon. There was just field labeled photon versus field labeled gravity. And that's the equilibrium. So that's where this comes back to my original statement about equilibrium. That the whole system is equilibrium. And what we see as imbalances in equilibrium are not imbalances in field energy. They're imbalances in orientation. So it's really just about this stuff. It's about that idea of a red or blue. And so it's this arbitrary element that's really the only thing that's being changed, and the thing that makes us think or see or distinguish between one thing and the other thing. We can filter for red or blue. And so if it can make something red and make something blue, we will see the difference. Matter can identify the difference between those two things. All right, that's probably a better way to say it. All right. So I will make a square, and then I will make another square, and then I'll make another square. So we'll use that to identify atoms. Probably should do it for electrons, but let's just do it for atoms for now. And so the idea will be simple, is that stuff interacts. So stuff is going to come in here, move this into this, and what really is going to happen is this is going to have its field changed. It's going to encroach here, its field, which means that it's going to produce field energy, field residue that's going to hit this. And that field residue is going to be absorbed and do the same thing to this and move it. And then it's going to move this, kind of a thing. Kind of like what happens with gravity. So I've had the argument that gravity would have a limitation because as you got deeper and deeper into something, you'd be blocking gravity. And you're not blocking it by this understanding, you're converting it. And so you're converting gravitons into accelerating electrons. Same thing, the electrons are field energy, and to accelerate them, they are absorbing your direction. So it's still gravity, it's just in the form of a school. So it's still fish, just in the form of a school of fish. And it will eventually be converted again back into loose fish. So obviously any acceleration you have towards the center of the gravity of a gravitational body, as you're accelerating towards the center of gravity, obviously you're going to have to release that gravity, that energy, that acceleration is going to have to be decelerated reasonably. You can't, or the matter on one side of the earth would just shoot through the earth and fly out the other side. It obviously doesn't. It does this equilibrium thing. So theoretically, the field pressure that's on the surface of the earth, that's moving us at whatever, 10 meters per second, you know, and halfway the distance it's at 2 meters per second, 2.5 meters per second. And at a quarter of the distance it's 0.5 meters per second, some number like that. So the mass of the object, the mass of matter reduces, I mean the weight reduces as you get closer to the center. It becomes less heavy. And it's still the same thing, but it's less heavy in terms of velocity, in terms of more specifically acceleration. So it's only acceleration by gravity that gives things what we can call weight. But weight really is only measurable in a field that's sensitive to matter. So yes, something has atomic weight, but atomic weight means less depending on the circumstance. Probably a better way to say that. it's still a reflection of the imbalance. So the only thing that makes the weight significant is the amount of imbalance in terms of the mass to field. So when you're on the surface of the earth, there's a big pile of mass of matter on one side of you and a big pile of field on the other side of you. And it's that imbalance, how much matter there is to field, polarization versus non-polarized, could be the argument. So that's probably worth writing down. That's making your mass significant. So mass is significant when there's more matter than when the proportion of matter to field. So how do you say that when there's more matter on one side of you and more field on the other side of you? You know, more matter on one side and field quanta on the other side. All right, so that's I think the valuable thing for the evening. That was a good one. So yeah, so let's just make the argument. I could make the argument that there's the same amount of stuff. You can't weigh gravitons, but like a photon, they have mass in one direction. So just because they are invisible, except when they're not invisible, right? I mean, they're just as visible as a photon in the sense you can't see a photon go left or right. Okay, you can't. It doesn't leave a trail or something. You know, it doesn't reflect light off a photon, so you can't see a photon. And likewise, you can't see a graviton, but in a sense, you can see their effect on you. So clearly, they're there. They have mass in one direction, just like the photon. So the atomic weight of the stuff above me is the same as the stuff below me, even though the Earth seems like that's more stuff. It's the same stuff. There's the same amount of stuff. It's just that the stuff coming down on me, the gravity, is randomly polarized, and the stuff below me is not. It's geometrically polarized. All right, that's a good word. Geometrically polarized. It's the polarization is in geometric configurations, orientations, places, certain cables, so to speak, if they were all made out of cables. And those certain cables create that circle-y thing. It's like the aperture made out of straight pieces of metal folded on top of each other. It creates a flexible aperture. Well, I don't know, that's probably a more complex example. Spokes on a wheel is probably the best way to understand that they have an orientation and they're all consistent. Okay. All right. So we have the same distribution of mass throughout the universe. All right, same distribution of mass. It's just that, well, the trick would be is that take some place. I'm just thinking about if I go farther out in space from a gravitational body, all I'm really doing is changing the shadow pressure, but I'm still being hit by the field pressure equally. So I'm getting hit by as much gravity. Let's say if I was moving towards Earth from left to right or whatever direction, one side of my body is getting hit by the gravity, one side is on the shadow side, the side the Earth is facing. Well, if I move further away, I'm still getting hit by the same amount from that way. The thing that's changed is now I'm getting hit with an equal amount from this side. So what we think of as empty space is space full of pressure. You get it because you're not getting shadowed. So empty space is almost like, in a kind of way, it's the densest field because there's no shadows. And the shadow is just created by changing the polarization of the gravity to a polarization invisible to you, to your matter. Your matter is affected by certain polarizations of gravity, and it doesn't feel others. So even when you're being pushed by gravity, a percentage of the gravity is going right through you because your matter is not polarized to that percentage. Nothing in you is polarized to that percentage. I guess nothing, to say nothing, it would be silly, but you're less sensitive to it. And so that's the whole function of magnetism, is twice as sensitive to one form of polarization, 0% sensitive to another. And that would have the same effect as creating magnetism, much stronger force, and if you polarize the gravity. And yet it wouldn't change gravity because the gravity has 99 other polarizations, and you've only affected, well, 98, and you've only affected 2. So to speak. All right, so yeah, so that works. All right, so same distribution of mass in all space, including matter. Okay, so that's kind of interesting that the field in empty space contains a tremendous amount of energy in the form of unrealized gravity, gravity undisplayed, gravity that's potential but not being actively revealed, and that gravity always exists. So again, it's exactly the same amount of force on one side of you if you're next to the sun or if you're next to the earth. Even though the sun is 7 times more gravitational, your weight is 7 times greater, it's the exact same amount of force hitting you from the one side. And the only thing that's changed is the amount of force hitting you from the other side. And by force, we're really just talking about polarization. Okay, polarization. Is the key to gravity's function as well. So I mean, even gravity is working on polarization, like magnetism. How to say that? All matter is polarized. It's just that magnetic matter is polarized in a very specific way that makes it capable of doing this double zero thing. Yeah. All right. So matter equals polarization. So that's another way of saying color. Quote unquote. It is easy to use color as an analogy, but I really hate to go there. These colors associated with frequency, and we're talking about polarization. But we're really talking about filters. So the real key is that polarization establishes this idea that things in a row, things that have a this versus this, you can understand that you can build two kinds of cages that way. You can build cages that have all the bars going this way. You can build cages that have all the bars going this way. And then you can have a cage that has bars going both ways, little squares. So maybe that's worth drawing. So you can have up and down lines, you can have horizontal lines, and then you can have both. And another key thing is that to go from horizontal to vertical only requires a quarter turn. So the opposite, so kind of the opposite of this isn't this, because that's exactly the same, right? Vertical, 180 degrees is still vertical. So the key is that it's the quarter turn that creates the opposite. So the opposite is created with a quarter turn. And I think that's really important in terms of magnetism and the switching of the domains. The domains aren't flipping 180 degrees. They're just turning 1/4. And that's why it's more, you can kind of understand something doing this as a mechanical function, is kind of, that would be kind of easy for something to be turned like a clock in either direction. But something flipped, that's hard to imagine atoms flipping. Atoms turning, yeah, that you can get. Atoms flipping, that's a lot more complicated to think about how electron would flip, and then the location of the proton would flip. You know, and if there was any irregularity in the shape of the arrangement, that somehow that would be able to flip. Like if you had 3 electrons on one side, 1 electron on one side, blah, 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 how could that possibly flip? Because spatially, the puzzle pieces wouldn't fit. Where if you think of that quarter turn, you just think of them all quarter turning. Yeah. What did I write here? Obstacle. I don't know what I wrote. That's really annoying. Opposite equals 1/4 turn. Okay, that's a big idea there too. All right, so yeah, I've done pretty well, and I've only drawn 3 little tiny boxes on there. Yeah, got a lot of progress, and just 3 little boxes. So yeah, I just need to. I gotta devote more time to this stuff. You know, hopefully I'll find more time. You know, just to. You know, I shouldn't mess with the gardening stuff because that does suck up a lot of time. But it's good for my interior. My polarization finds it conducive to maintaining my equilibrium. I have some sort of distraction from the harassments of the irritations of the problem solving and the puzzle doing, and the irritation, the aggravations of all the unnecessary obstacles to um, having this fairly processed through the machinery of the social recognition, or instrumental or useful recognition, however you want to put that, that this theoretically does fix all the problems that exist between quantum mechanics and the big universe, and quantum mechanics and rationality, for that matter. Yeah. So, yeah, it is. Yeah, I mean, I don't want to get into a bunch of psychology stuff, but it's kind of funny how at least my brain, that you hate tedious stuff. I mean, too redundant, too tedious. But when you're doing complex things, it's like your brain starts really getting hungry for the potato chip, of something simple. It wants to just put caps on pens or something. It wants something really, give me something easy and controllable, because your brain kind of gets tired of the uncontrolled and complicated. And then vice versa. If you're stuck with something too simple for too long, you really crave, a more complex puzzle to solve. But, it's all Freudian stuff in one way or another, I suppose, or whatever. I mean, there's probably a deeper explanation of why that's evolutionarily something that happens. Why, I guess it's more like the waiting thing. Well, I don't want to get into much evolutionary theory, but it's probably that, you're designed not to waste time. So, like if you're waiting for an apple to ripen on a tree, your brain has a mechanism in there that says, no, you can wait for 10 minutes, but you're not wasted more than 10 minutes. If the apple don't ripen in 10 minutes, go do something else, because you're investing too much time in this fucking apple. So that's probably what the mechanism exists for, is just to break our capacity to just sit around and stare at something for 5 days. So there has to be a mechanism to prevent us from doing that. So it has to make it tedious, obnoxious. We have to crave for something more. Something like that. So I'll get back to the drawing and try to get some nicotine and such. But I like where this has gone so far. Got some good concepts here. And in one respect, Hathaway was a little bit useful in this one element, in the sense that he did. I don't know whether he highlighted it before or after. It probably doesn't matter. But it's an important point, that as much as I like this kinetic model, the only part of the kinetic model that matters is the interaction thing, in the sense that something changes. There has to be a change. And the only thing that can change is polarization. So you can change something that was this, and you can change it into something like that. And that can happen inside matter. So inside matter, a quanta that's shaped this way can be exchanged for one going this way. So a quanta going the opposite, say they're going the opposite directions, but it might be the perpendicular directions. The point is that if this one was this way and this one was this way, the two of them will switch their polarization. And now this one's going still this way, and this one's still going this way, but now the polarization has been changed. And that's what matter does. And that's the only change that happens in all of the field energy. So all the field energy is still doing all this straight line stuff. It never changes direction. The only thing that changes is whether it's doing this or doing this. That's really amazing. But that's all you need to create a whole universe. and apply frequency. Frequency is sort of irrelevant, but frequency is just saying that you converted two of these into this at exactly the same distance from each other. So two things that were this, you turned to this, or you took one that was this and converted to this, and now they match at the same distance. And that's all that light is. It's just a ray of light. It's just things of the same polarization at a consistent distance from each other. But again, the only thing that really changed is polarization. So in a ray of light, there could be lots of gravitons in the ray, but they're irrelevant. So like in a radio wave, there's probably lots of gravitons in between the two polarized elements, the ones that have the same polarization. And they're the only ones that become what we call the energy of the radio. They're the only ones going to be absorbed by an electron to create acceleration. Very interesting. Okay. Oh, we got questions. The brain seems to do pretty well with assessing our relation with hands-on things opposed to sterile abstractions. Oh, I'm not too sure about that. I mean, you could argue that it just depends, I guess, on how sterile the abstraction is. I mean, my body certainly, my brain certainly enjoys the abstraction of imagining a naked woman. So, I mean, it certainly can make abstractions it finds intriguing and interesting. So, I don't think that's really it. And you almost could argue that a video game is pretty close to an abstraction. I mean, it's pretty close to something your imagination created. It's just like an imagination aid. It's like a crutch for your imagination. Not much more. Unless there are some sensible metaphors involved, I suppose. Well, yeah, sensible meaning suited to your sensibilities. So yeah, so sensible based on the concept of sensibility or taste, I would agree. Sensible in terms of rational, I'm not too sure. Pretty much. Okay, so I do have a red pen and a black pen, so I have to start drawing arrows. Yeah, but maybe I need something better than that. Well, I guess we'll just use those to quantify polarization, and then we'll see what we can do. But then I guess I would have to use some other color to signify all the irrelevant arrows. I need some way to make gravity light, and magnetism. And it's just they're too different. I mean, the magnetism is all about polarization, and the light is all about frequency mostly. I mean, it's polarizing, but it's frequency. And then the gravity is just the fact of the indistinguishability of it as polarization or frequency. The fact that it has neither one of those things in any dominant proportion. Let's see, there's a cave on Earth where gravity works like a repellent to mass. No, there really isn't. Do you really think there's a cave on Earth where things just float? You think so? Really? Really? I mean, it's kind of silly when you start a sentence like that with a premise, there is a cave on Earth where gravity works like a repellent to mass. And then you ask the second question, how does that work? I mean, shouldn't you first be able to establish the existence of this cave and that it actually has any features, let alone the feature of repelling mass, whatever that means? I mean, does it repel in any direction? I mean, if I take the cave and tilt it, do I get repelled against into the right to left? Does it push me to the right? Sorry, it just doesn't. Yeah, sorry, it's just crap. There's no such cave. At best, something could be magnetic, and then it would affect things that are magnetic. Something could be electrically charged, and that could even have an effect, but that's, again, just kind of magnetism. But there's no repellent to mass thing. I guess I should have put that as visualizable objects opposed to just symbols artificially crafted to represent them. Yeah, well, again, I don't think it really matters in terms of how the brain perceives. So we're fooled that it somehow matters. We think it matters, okay, whether you actually see something or whether you imagine it. So I just close my eyes and I see this pen in my hand. I see it. It's like I'm really looking at it because I know exactly what it kind of looks like, and I can exactly kind of understand that I'm putting it in different places in this field because I know my senses are pretty reliable about location. And so even though I have my eyes closed, I see this pen. Even though I don't really see it, you know what I'm saying? It's black and I'm just seeing black. I see it in a sense that my brain manufactures it. And it doesn't even manufacture it as a clear image. I mean, even tilting it, my brain sees that. It senses it. It understands it. And I don't think there's that big a difference between me seeing it and me seeing it in my head. In the end, you always see it in your head. Your head just creates a perception, and it's either a rich, detailed perception that is more interesting because you can see the details and your brain can be triggered by all the details, or it gives you its representation of it, which usually is like a cartoon version. It's very dull in terms of detail, and so your brain doesn't do a lot of thinking about it because there's not enough triggers on it. You know, you're not triggered. So when my brain imagined it, I didn't really imagine the clip, you know, the metal clip on there. Didn't imagine that. It didn't bother with that detail. So I wasn't hit with it, you know, visually. But I'm just saying that impressions are all we have, either way. You either have the impression created by your imagination, or you have the impression created by visual stimulation. But either way, your brain is manufacturing the impression. The photons aren't the thing. So the light bouncing off the thing is just a way of communicating the idea of the thing. But it's still the idea of the thing my brain's manufacturing, both visually and as an understanding, as a conceptual thing. But I guess I'm just saying that I'm just arguing that it's all your brain manufactures perception. Either way, it's just that one perception is intrinsically has more information available. This external pen, seen with my eyes, has more contextual information than what's stored in my brain. So it's always going to have an advantage in terms of having more opportunity to stir up thought. Let's see. Oh, a fake Inmendum account. Isn't that cute? Jeez, what are you, retarded? You know how easy it is to just block somebody in here? I mean, it's so easy. I just hit this little thing and I go block user, and that's it. It's that easy. Why isn't that clever? He muted me. I don't know why they give people that ability. I mean, you know, YouTube does some silly things, but why would you give guests the capacity to mute the host? I mean, that's just fundamentally retarded, isn't it? I mean, there's just no reason for that, right? I mean, Google has the most expensive engineers and software guys in the world, right? I mean, that can't possibly be a deliberate feature, can it? I mean, they sort of should just be mocked. I mean, I wish there was a place where you just go to companies and you could just mock them and say, hey, I want to mock your software engineers, because there's no way you can come up with an excuse for that. It's the dumbest feature in like all of the internet universe would be to have a room where the host gets muted by the guest. I mean, where else in the real world would there be anything analogous to that making any sense? That's like somebody else having keys to my house and I don't have a key. I mean, that just doesn't make any sense. Oh, yes, well, Horsecock, you're just so interesting. And that's just such a great argument. No, it really isn't. Yeah, they're not just assertions, they're explanations, you cunt. Fuck off. This is amazing. Could be a blunder oversight, I suppose. Well, I just mean, how could it be a blunder? You just have to open a room, right? You're like a Google guy. You say, hey, let's try this out and see how it works. Okay. Hey, that guy just muted me. Yeah, that's not a very good feature, is it? No. Horsecock just came into the room and muted me. Oh, okay. Yeah, let's fix that. That's stupid. I'm just saying. There's just no, I mean, I just can't imagine there could be a rational reason. There just can't be a rationally good reason. They're obviously not as smart as we're told they're supposed to be. That's my argument. Well, it wouldn't be just naive. It would be completely insane. I mean, again, what purpose would it have? What, I opened a room and then I go preposterously insane, and fortunately, somebody in the room mutes me. because I go preposterously insane. And the room's still open though, and it's other people. The guests are now using the room. I went insane and have been muted because I went insane. I was scared. There's no rational scenario. I mean, can you describe a scenario where having the guest mute the host could possibly be a good idea? It's not drama, asshole. I'm taking a break. Stupid cunt. I'm allowed to do that. All right. So anyway, I'll get back to the physics. Yeah, it's hardly drama, and frankly, I do have to moderate the chat. I mean, if I don't block them, then they'll just fill the chat full of crap, asshole. Then I won't even be able to read your comment, cunt. Jeez. All right, so I guess I'll draw this as some other thing, just for the sake of, yeah, so black and red. Maybe I'll make black and red circles. And see, I shouldn't put these circles so close together because I can't draw shit between them. All right, so I'll draw 2 circles further apart. We'll pretend those are 2 electrons. And obviously the protons are involved in this exchange thing too, but I'll just leave them out for now. But it's probably important to the, you know, reversing of the entire reversal of polarization. I'm not sure about, see electrons, it seems to me electrons can forward a photon, you know, in a new direction. So an electron can deflect by moving forward. So that was another thing I wanted to get to, was this whole position thing is so important. So I'm just going to do a quick little drawing of that. So if we understood electrons to have a position, orbiting, let's say something here, the proton or whatever, are just in a field position. So let's just say they're extra electrons, free electrons lining up on, let's say, the magnetic lines of force emanating from matter. These lines of force combine into a bigger line of forces that we see, you know, the ones that the filings will line up on. But the electrons are probably lining up on smaller ones. But regardless, you can sort of understand that for the purpose of the 2-slit experiment, that let's say a photon came into this electron. Well, this one can stay straight forward. So the photon would again then just leave straight. But say if it hit this electron and moved it, gave it acceleration, its acceleration would be moving to this position because of the force laws, right? So you can understand that the field is neutral in this arc, and everywhere else the electron's going to be pushed to this field. So if the electron's out here, it'll be pushed in here. If the electron's out here, it'll be pushed in here, accelerated. But the point is, this is the neutral position. And so when the electron moves, it doesn't move in a straight line. It moves where the field, okay, where the field line is neutral. It wants to stay in the neutral. And so it's always going to find a neutral. So anywhere where there's an unevenness in the field, more positive than negative, that is, it's closer to a proton than it is to an electron, whatever the imbalance is, it's going to move in this crooked position. So even though a photon went in straight, the acceleration got converted into not straight, and that's the nature of diffraction. And then when it releases the photon, it's releasing it from a new orientation because it is in a different position, if you can get what I'm saying. It got accelerated, which means its head and its tail changed. And that's why it's diffracting the light. That's why the light gets bent. And you can sort of understand that the more, the tighter this arc gets, the more the diffraction that you're going to get. So the tighter the arc, the more distance it moves perpendicular to the forward motion. So the more the electron moves perpendicular, tangentially to its forward, to the direction of the photon, the more the diffraction, obviously. So I think that's an important part of that whole argument, which is a different subject, but it's similar. I mean, it's all related, right? It's all the same subject. Anyway, let's see, more comments here. Let's see. All right, more distracting. I'm not an asshole or cunt. Well, it says you. Prove it. Right? Everybody's arguing about proof. Why don't you, prove you're not? Cunt hole, perhaps. Okay, well, good enough for me. Skanky cunt hole. What do you think about the recently discovered trans-Neptunian objects that orbits the sun backwards? I think somebody already posted this shit. I don't think it's at all interesting. I mean, first of all, insignificantly massive objects don't have to obey the same rules as the rest of the solar system. There's obviously the amount of dampening, if you want to call it that. Their effect on the total field energy is minute. So it seems conceivable to me that something could come into our solar system, right? Or could be a long lost remnant, that had a very big orbit from when the dirty when it was dirty. Obviously, over time, what's happened in our solar system is all the bits have consolidated on the field lines, so to speak, where the mass is. Okay, the masses have cleaned up different areas, and everything's been condensed into those areas, right? I mean, wherever the heaviest mass is, like electrons, everything's been sort of moved to where the heaviest masses are, gravitationally within the solar system as a mass. But anything deep or having an eccentric orbit wouldn't be obeying those rules necessarily. First off, because their opportunity to get dampened is rare, because they only show up every 200 years. So their orbits are huge and they're slow. So the dampening effect, the consuming effect, is very, very slow. So these are all that is it's just an artifact. It's like a vestigial planetary bit that just hasn't been absorbed yet. It hasn't been forced to comply yet because it's moving so eccentric. But there's no the only reason why things are tending to move in one direction is because that's the once it goes in a direction, that's the direction's chosen. So it's like a random thing. It has to tip one way or the other. So in the initial circumstance, there was more stuff moving in the clockwise direction, let's call it, then everything has to go clockwise eventually. And if anything's going counterclockwise, it'll be consumed, because the 51% are always going to consume the 49% over time. So it's like playing Risk, right? Once you get behind in the game of Risk, you get behind really, really fast. You can fail incredibly fast because every time the other guy can outlast you. It's like capitalism and monopolies. The monopolies will win in unregulated capitalism. They'll just consume everything. I'm trying to use analogies, but that's good enough, I think. Well, you people just, keep bringing up all this little wishy-washy, mishy-mushy stuff. Anyway, let's see what this asshole said. Does this do anything for your argument or your theory? Well, I don't think it's terribly. I mean, it does something in the sense that all the dynamics within the solar system are evidence of gravity, and gravity is my subject now. So yeah. For if it's true, against, or not. Well, again, like I said, I just don't think it's that. I don't think it's something there that should not be anticipated. I mean, sure, there's comets going the wrong way too. How do you prove that in Mendham? Well, I prove it by saying I'm sure there's comets going the wrong way too. There, so is that good enough answer? How do you know the orientation is tangential? Sounds like a claim. Well, we know that force, magnetism, and electromagnetic force, so EMF, is always tangential, perpendicular to the acceleration of electrons. So I'm just saying if the acceleration is lost, in the sense the electron only accelerates to a given point, so it goes from point A to point B, then it has to accelerate and then decelerate. And through the process of acceleration and deceleration, it would be leaking field energy. But the point is it's going to give back the photon, so it's not keeping it. And that's the real point. So all I'm arguing for is the fact that through the process of acceleration, you let go force one way, then you eat back the same polarization when you decelerate. So you're eating back what you gave. So you gave 10 cents to the field, you took the 10 cents back, and when you took the 10 cents back, you released the photon. So in a sense, you absorb the photon, the electron accelerates, you're 10 cents in the hole. You pull the 10 cents back out of the field, and now you can release the photon, if you get what I'm saying. So the photon is 10 cents, it comes in, it gives you extra 10 cents, you shoot 10 cents out as field energy, you accelerate, and then when you decelerate, you take your 10 cents back from the field, so it's all the same dime, and now you can release it because it's an extra dime anyway. You see what I'm saying? The bank always stays neutral. So whatever goes in has to be converted to something else, and then it can be reconverted back into the thing. So that's all that's happening. The energy of the photon is absorbed. Tangential fish are released. Tangential fish come back in when you decelerate, de-accelerate, and now you can give back the photon. All right, so anyway, you know where the electron is, you washed up sea hag. You know where the electron is, you washed up sea hag. I don't even know what that means, but you know, whatever. Fuck off then. I don't even know. Wait, let's see what you look like, asshole. Please. You know, I bet I'm, you know, so much better looking than you are, asshole. You're probably fat and dullaried, and you probably have a very small penis. Yeah. Okay. I read some news about NICU. To me, it just seems like an innocuous anomaly which wouldn't be problematic in regards to physics theories. Maybe it would be to cosmological or solar system evolution. Yeah, I just don't think it's, I think it's interesting. I mean, I haven't read anything about it at all. I didn't know anything about it, but I'm just saying it doesn't seem to me to be unexpected. I guess that's what I would say. I think you would expect there's still to be bits in the universe that are still pretty fucktarded, especially out past Neptune. I mean, you're talking about a long fucking way away, and it's hard to clean up the dirt. The further away you are from the vacuum cleaner, you know, that dirt doesn't get picked up as easy. I'm sure ain't a good answer, Richard Plunk. What? I'm sure ain't a good answer. And I thought I already blocked you. Usually your comments get deleted when you've been blocked. So I'll delete you. I'll block you again. How's that? Yes, that would be fun. Okay. I don't know why the comment's still there. It's just kind of funny. They didn't choose to. Well, I can delete it, I suppose. Then I just take it out of sight, out of mind. Still didn't get rid of it. That's really bizarre. Well, anyway, enough of that nonsense. Trolls, assholes. This planet Earth covered with them. There should be a law, frankly, in my opinion. It makes perfectly good sense to have a law. Fuck assholes. That should be the law. Let's fuck them. Let's go find somebody who's just all asshole and fuck him. Yeah. Unpleasantly. Until he learns to be something other than an asshole. I mean, just, Gutless cowards. They're little anonymous trolley accounts spouting their crap. No accountability. They put up nothing. Don't put their integrity on the line. I really should be able to call them out and shoot them in the head. I really think so. Should be able to do the world a favor and dispose of the rubbish. Is this the right one? Oh, I can't find my nicotine. All right, so I do have to get to my arrow thing. All right, let's see. Put them in stilts, or whatever they called. No, those were, yeah, what they call those things. There's a better word for that. I should know that kind of crap. I remember, I went to all those places when I was a kid, Jamestown and all that, and they had all those pillories, put the thing over with your arms out and your head stuck in it, and can't remember what the name of it is. I guess pillory is good enough. Well, I'm not saying I'm an advocate for, yes, I wouldn't fuck them with my dick. I would fuck them with, I don't know, toilet bowl brush or something. Toilet bowl brush. Something like that. Just shoot them. I'm not all that, I really don't think there's even much point in reclamating them personally. I wouldn't mind having like troll camps, like concentration camps for trolls. I wouldn't mind doing that either. Stock, there you go. That's the word I was looking for. No, still a better word. But yeah, I know that there's some other word, stock and something, or something and stock, or I know there's more than one word. I think it had the word block in it or something. Because it was like a block of wood and stuff. I think block is in there or something. I don't know. Anyway, enough of that. Ugh. All right. So we have equal amounts of force. And what's changed is some of the force comes in a certain orientation. So we'll just say that this orientation is a photon, which means it is polarized and has a frequency. I'll indicate polarized with, how do I do that? Yeah, double arrow. Let me see if that works. I already have double vision, so that doesn't really work. I guess I have to have more colors. Maybe I'll use the thick marker. No, I don't know. That won't solve my problem. Stockade. Yeah, well, stockade is a word used for like a, little pen. So that, but yeah, it does sound right, but it's not right. But it sounds right. But anyway, all right, enough of that. Stock and pillory. I think that's close enough. I said the word pillory before, so that makes sense. And I said stock makes sense, so stock and pillory, and then those are two words. So that one makes sense to me. But it doesn't really matter. All right, so then I have to have a way of describing the acceleration, the actual acceleration of the thing. So I have to have some symbol for that. All right, so the idea is going to be I'm going to come up with symbols, or a way to represent quanta going in, and that'll be represented as these arrows all having a quanta, So this would say be a balanced thing. The thing has as much arrows going this way as every other direction. And then something goes in, it causes the thing itself to accelerate, which means that this one arrow is divided among all the arrows in here. So you divide 1 into how many arrows there are in total here. Now, the only problem with that is some of these arrows are already going in the same direction as this one. So you have to do it by the 3/4 kind of math to really talk about how much change there is. So for one to change one going the opposite direction would cause you have to do 180 degrees of turn. So that's 2/4. And for the quarters, you only have to do a quarter turn to get them to go the same way. So that's what changes the mathematical equation. So the math is going to require a little more work, because I can't just divide this into the total fish, because some of the fish are going in the same direction as this, and they can't negate each other. So you don't need to make the fish that are already going the right way go the right way, in other words. So the part it has to be spread over is all the fish going tangential or going the opposite direction. And that's how much acceleration the electron can possibly gain from the absorption of, say, the photon. Now we know the photon is 2 because of the frequency thing. We know it's at least 2 quanta for 1 photon. So 1 photon, you always has to count to establish the frequency. It has to be a 2 thing. And like I said, I think the idea of the 2 is just a way of recognizing that to have an orbit, you have to have something on one side and you have to have the equilibrium of the thing on the other side. So you have to have things come in at exactly the right orbital distance. So by the time this first arrow goes to, I mean, it doesn't actually do this, but till its energy, okay, or its essence, its whatever, reaches this point, or would have, let's just say, the time it would take this first cannonball shell, let's say, to orbit the moon, so let's think of it in that kind of sense, where it would get to the halfway point. So it comes in at some point, and it has to get to the halfway point before the other one shows up. Then the 2 will be opposite each other, and therefore they'll have equilibrium gravitationally, if you can sort of understand that. So that would be that's why there has to be 2. That's why frequency is important, is because frequency establishes a pair. And you have to have pairs to create orbits. You have to have 2 of something, okay? You can't orbit yourself. Earlier in stock is the word. Good. Anyway, so where was I? All right, so you can sort of understand, if this stuff's moving at the speed of light, that speed of light will be divided into, divided by, however you want to put it, divided over the 3/4 of this thing that aren't going the way the light came in. And that will determine how much speed how much the electron accelerates. So the thing went in, the electron accelerates. Now, when it accelerates, it gives off, because it's an accelerating charge. So what we know is it gives off tangential fish. So something like this happens. Okay, quanta leaves in the tangential direction. Now, it can have lost the frequency, but the frequency information is still in the field in the sense that that information still exists. But now that the acceleration, so once the electron accelerates, it does this. It releases polarization in these directions, tangential to this direction. Now, this stuff is still moving in and out. So this isn't new energy being released. This is just labels. So just recognize that. I guess I should make these red if I want to have red go out, but but it is being converted. So let's say it is converted. So it goes in black. It gives off red tangentially when the electron accelerates, moves. So now the electron's in the, now it's going to decelerate. So how do I write deceleration? Yeah, I don't know. Because it's going to come in contact with another electron. Okay, so this electron is stable in its position. This one was stable in its position, so I'll put an X on those. So this one was stable. It got hit by a photon. It absorbed that acceleration and now moved to this position. But the problem is there's an electron in front of it. And that electron is producing field energy that's going to decelerate this electron. So in a sense, it's throwing fish at it this way. And so now it's going to have to absorb the polarization that it gave away when it decelerates. So now polarization red comes into the field and it keeps it. And essentially, like I said, this is a crude version of it. So you can sort of understand that while it accelerates, it expels stuff. When it decelerates, or that is, it goes back to having a fixed position, it loses that acceleration. It will now consume the polarization that it released before. So now it's taking from the field. So this is the, so you have to understand that the field is out here. And that whatever goes out of this goes into the field, and it exists in the field, and then it can be reabsorbed from the field because the field is constantly interacting through this whole process. All right, why are we conscious? Wrong subject. Oh wait, I should ask that because I know nothing about consciousness. It would be like asking, why do we have legs? You don't know the basics of legs. Well, no, it really wouldn't. I've done tons of videos on the Inmendum channel on the subject of consciousness. The reason why we're conscious is because it works. It creates behavior. So first your brain creates value by having a sensation. Then your brain strategizes solutions to fix your feelings. And that's how evolution makes stuff in the environment matter to the robots that we are. It motivates the robot to do something based on a circumstance in the environment. But the simplest answer as to why we're conscious is because it works. It creates behavior. All right. So anyway, you're really off the subject. You want to do that kind of shit, do it someplace else. I mean, this isn't the room for consciousness conversations. I think it's kind of obvious it's not. I don't know why exactly you're bringing it up now. You could do that someplace else on some other channel. So do it again and I'll just block you. How about that? Well, anyway. It doesn't have to work better than anything. Evolution doesn't work that way. Evolution isn't survival of the perfect. Evolution is survival of the thing better than the other losers. Okay? You don't have to be, it's like the smartest man on earth is a dumb motherfucker. Okay? It doesn't make perfect things. It doesn't make great things. We have most of our genetic code is archaic nonsense. We have tons of genes that are just about how to make scales and how to make a coating on our eye for swimming underwater. I mean, we have genes from back when we were fucking bugs. Right? The system is dirty and stinky. It isn't brilliant. Anyway, back to the physics subject. Shithead. Anyway, I don't know. I think it's kind of obvious I'm doing physics now, not brains. I just think it's kind of obvious. I just really don't understand why you can't get that. But whatever. I don't understand people at all. So anyway, so it accelerates. So I have to come up with a way to show deceleration. So the deceleration is because something causes the deceleration. So obviously it enters a new field created by this other electron. That field says you can't go here. And so it decelerates, and in decelerating, it absorbs this polarization, okay, from the field. And now it has to give back this photon. And so the catch is that this frequency will be retained and this photon will leave. In this case, I would imagine it has to leave going into this new, the new obstacle. So in a sense, the original, I don't know how to, don't have enough room to draw it anyway, but the original, I'll just make one of these kind of things, arrow pointing to arrows. So the original photon, started here, and it will end up getting thrown right at this electron, and so it will basically duplicate the same process. And that's how the energy in the simplest model would migrate through. So it accelerates an electron, creates field, reabsorbs the field. So that's the movement in the electric field, right? Which is kind of important to the idea of creating charge in like a conductor or something. So through acceleration and deceleration, you create a transmittable field in the sense that you allow another field to excite and unexcite. So in a conductor, what's happening, let's say this field had a conductor running through it. There was a wire in this broader field. The wire would have the field energy would come in, and that would push everything out of the conductor. The electrons would be excited in both directions. But then when the minus part of the field, where it's pulling polarization out of the field, it collapses this push, and so then it's able to re-enter. So the electrons will now accelerate back in to the conductor. So that's why alternating current works, is because it keeps clearing the field, closing the field, clearing, allowing it to collapse, opening, clearing or collapsing. So it's essentially creating a, it's like you blowing on something that's elastic, or this is not a better example of something that clears and then it stops and everything just comes back because there's pressure. The electrons don't like each other. They've been pushed together. Now they want to fly back into the empty space. And so that's how you transmit electricity into a conductor, is by collapsing a field, by creating a field and then collapsing it. Is the only way to make movement that's constant. Because if you just have a constant DC field, so you just have the field created in one direction and moving into a conductor, it just pushes all of the electrons out of the conductor, to the ends of the conductor, creates an initial voltage, but that's all you have. Then everything just, there's no ability for the electrons to migrate back into the conductor, accelerate back into the conductor. Pretty much. Cat wants to come in, so I'll take a little break. So entertain yourself for a second. Should just be a minute or so. Just got to give them a little food and water and such. Some kind of sloppy down your dish. Molded food. Yeah, I'm working on it. Damn animals. Nag, nag. All right. I think I completed the task. I believe I'm done. Mostly. Yeah, so where was I? I'll read comments. All right. I ain't watching that. You need to make a chat room for all science topics so you can win a Nobel Prize in every field. Well, that's true. Whatever. Why don't you label links? I mean, I'm not watching something unless you can label it, asshole. I mean, I don't want to watch a music video. I don't know what the fuck you're linking to. Climate change, question mark, LOL, question mark. I don't know what that means. How is it relevant? How about the humanity in the Northeast? How about the humidity in the Northeast? I mean, you know, yeah, it's really bad. But I really don't want to, you know, I'm really trying to do physics here. I really don't want to do this weather shit. Jeez. Well, yeah, I mean, it's not that harsh in a lot of ways. I mean, what, 7 years ago, we had like June 1st, it was 103 degrees on June 1st. You know, we haven't had anything like that in the last 7 or 8 years. I don't think we've hit 100 degrees in 5 years or 4 years. Why don't you do something else, shithead? He wants to go back. It's too hot in here for him. Pussy fucking cat. All right, I'll be back again. I'm giving food and he just licks the gravy off of it. Okay, I know the cat isn't much of a subject either. All right, so so I was talking about the field and conductor. Yes, I already did that part. Yeah, so I think this is, I just have to come up with some better symbols, but I think we have the basic idea here that something comes in field energy goes out in the perpendicular, and then it goes back in if this acceleration is absorbed. So once the acceleration stops, like in a mirror, then the energy is transferred, and eventually in the mirror example, like because it is a metal, I think this is what is where the change takes place, and then you release what is field energy going the opposite direction, and you just relabel it. So that's the key. That's the part that has to be redrawn, is that in this example, field energy is coming in both ways in equal amounts, and all that's going to take place is that the label of photon here on one piece of the field energy is just going to be placed on the stuff going out. So all of this will happen, but the end result will be all of this will be absorbed into just a photon leaving this way. Yeah, so everything else will be eaten by equilibrium, by a dampening, and it'll just all be dampened eventually into relabeling field energy with the same polarization in the opposite direction. Well, I don't know what you mean by actual facility. I mean, again, just waste my time. People don't answer me emails. Publishers aren't interested, okay, because the people who decide what gets taken or given to a physicist to judge isn't a physicist. Okay, so he just says, oh, this guy is talking stuff I never heard of. He can't be right. That's all they do. So just don't waste my time, okay? If you got some fucking person you think's worth contacting, then give me an email address, or otherwise just shut up. Jeez. All right, you've told us already, just kidding, keep it up. I don't know what, I don't need just kidding shit, okay? So, I don't know what, like I said, just push the button a little bit harder and I'll just block you. I'm really not interested in playing mind games or bullshit games. So if you can't just say something straight that's meaningful or useful, fuck off. I'm just saying, who do you think does this friendly meeting crap? And it's the fucking internet age, retard. I mean, this comment is idiotic. So if you actually meet them for a friendly meeting, why would you do that in the internet age? Would you, if there's a guy in Japan that you want to talk to, you would actually fly to Japan to talk to him? You do that, jackass? Fuck. I've published publicly. I make public videos, and I have open rooms. Now, I don't know exactly, like I said, I mean, what exactly, I've offered $5,000 to a physicist with a reputation. So any physicist who's got any kind of reputation at all, if you have, say, 50,000 subscribers on YouTube or above, or you've written a book, or you're been on CNN, okay, as a commentator, as a physicist, yeah, I'll pay you $5,000 to critique my theory. I mean, what else can I do, jackass? Yeah, you don't have to put copyright symbols on anything. Okay, I mean, you know, copyright is in the publishing, jackass. I can prove precedent. I can prove I published first. Shit for brain. You know, people just keep asking stupid questions. I've contacted a couple of publications. Now, they're a pain in the ass. First, you have to format everything the way they want it formatted. And like I said, you're presenting it to an asshole. You're not presenting it to somebody who knows what the fuck is going on. And they're going to decide whether a physicist actually is obligated to read your document. You know, and it's just for they just want stuff that's conducive to their published audience. So again, they seem to avoid controversy like the plague. So I'm just saying it doesn't seem like the route to take. So yeah, and I have contacted physicists privately, but again, like I said, they don't have much incentive. Me making them look stupid isn't really to their advantage, is it? Yeah, well, I mean, I just start talking about Huygens or something and ask them, why do you believe in this shit? The infinite mini waves. Why did you fall for that? You took 5 or 6 or 7 years of physics, and you're stupid enough to think there's an infinite number of mini waves created by every wave in the universe? Well, that's pretty stupid. Why'd you fall for that? Yeah, well, the Clifford guy, like I said, I contacted him 2 years ago. He's quite useless. I don't even think he's that good a physicist, frankly. He seems more interested in his trips to here or there, talking about absolute bullshit. I mean, his blog is, boring as fuck. Yes, I saw it. I did a video and I mentioned it. So, yeah, I guess I'm going to get to that one next. Well, I'm going to get to the quantum tunneling is even stupider. Anyway, the point is there's not a system really built into physics to take on the job of debunking, and that's why the #1 viewed physics video on YouTube is Dr. Quantum, and it's an absolute piece of shit. And the fact that physicists don't do anything to fix that, to make a counter video to say, hey, wait a minute, that's saying shit we're not really saying. Please don't put our name on that. Just demonstrates that it's just not really science in any good sense of the word. They're not looking for the truth. They're selling books. Yeah, the light went out. It's really not that complicated. You can buy these things called, for the outside, they detect motion detectors, and they'll turn lights on and off. Yeah, I have a motion detector on the light. It's not incredibly bizarre technology. It's called efficiency. You see, I don't have to turn the light switch on and off. Light goes out when there's no me around. It's kind of smart. I actually have one in the kitchen. I have one in the hallway. So light goes off when I'm not there. Look, I'm just saying, I haven't seen any example. Show me the example where physics is taking any responsibility to debunk the crap that's out there. Show me anybody engaged in a conversation, an argument somewhere. Show me where physicists have arguments about physics. Show me. Anyway, I mean, at best, they'll point out now and then how they'll mock each other a little bit and say, well, yeah, I don't really go for that string theory stuff, ha 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 ha. But they have no argument about the actual theory. They don't do any argument about any premises of physics. All right, why do we have to show you? Why can't you join their debates? Well, again, show me a debate. Like, show me one. I'm just going to block you. I'm sick of you. Fuck off. Too late. I'm sorry. Fuck you. You're not sorry for anything, cunt. Well, I don't. This China left in the dark theory is kind of silly. China's doing most of the new physics, you know, a lot of it anyway. Most of Britain's physics positions are held by Asians now. I mean, it's, you know, they really are taking over. Which creates a whole new problem, I suppose. Lots of language problems. Well, frankly, dark matter is a god, right? Dark matter is like God. He doesn't have any existence. He does special things. So he has impacts, and he produces force, and he does all kinds of stuff, but nothing can be reflected off of him. Can't see him, can't find him. He's invisible. I mean, the Invisible Man and God, right? That's about the same thing, right? Except God has superpowers. So let's just say take away the superpowers and just make him the Invisible Man, right? So it's just as silly. And that's all dark matter is. Just completely an invented concept. We don't know who did it. You know, it's like Columbo showing up and saying, well, you know, there's lots of this dead person, and I don't know how it could have happened. It must have been the Invisible Man, right? He did it. Yeah, Invisible Man could have done it. Yeah, it perfectly fits. He's invisible. Nobody saw him. He came in and he killed the guy, and then he left, and he's invisible, so nobody saw him. And the camera was on, but you didn't see him, so he's invisible. So no evidence. Why do you keep bringing up crap like this? The primer fields. It's just this electric universe crap. It's fucking nonsense. Why are you wasting my time with this gibberish? Ugh. There's no fucking interesting anything there. Ugh. I mean, wave theory is wrong, and these idiots think they've taken wave theory even further. So they fucking got it wrong by having any wave theory in physics. You show me physics that has 10 times more wave theory. Yeah, it's 10 times wronger. I mean, they shouldn't even call it primer field. Like I said, it doesn't have anything to do with fields. It has to do with a bunch of wavy nonsense. How do you make a field out of waves? It's just silly. And a dead medium won't create anything. See, that's the catch, right? They all basically are creating the ether, and even real physics is doing that now. You know, they're sort of recreating the ether, but they're always going to get it wrong because they're going to keep creating a dead ether. And the whole point is it's obviously not dead. That's what gravity is, the dumb fuckers. They don't get the obvious. You know, now that Einstein has taken gravity and slid it out of reality, you know, put it into bent space, time, dimension, Now they're it's even harder for them to understand that, oh, quite obviously that's what the fucking field is made out of. It's made out of gravity, and quite obviously gravity's not dead. It couldn't move planets if it had broken arms. I mean, obviously it has to be a fucking energetic field. It can't be a dead field. Yeah, well, I totally annihilated the two-slit experiment as described. I mean, I've nailed that one now, I think, completely. It's utter rubbish as a foundation for quantum mechanics. The two-slit experiment is absolute nonsense. Doesn't come close to proving anything. Well, they're obviously made up. Look, I'm going to make this argument. I've made this argument a million times. The whole concept of using an accelerator, to some extent, made sense in terms of ripping atoms apart. But what they're doing now is essentially smashing a Volkswagen into a Volkswagen, and a bunch of crap flies off. And the crap is charged, let's say, statically. And so then the crap moves and migrates, back into clumps. So it's almost like the metallic man from Terminator. You can shoot him and he'll blow up because he's frozen, but he'll end up wobbling back together again. And so that's all they're really doing, right? Is they're smashing Volkswagens, and then the stuff is reclumping back into parts. But most of the stuff they're finding doesn't exist but for milliseconds. So it's not like an electron flies off and it's like a real thing, you know what I mean? Or a beta particle. These aren't like real pieces of an atom. These are bent pieces of fender and shit. They're scrap metal. So yeah, when they find their pieces of scrap metal, all they're doing is they'll have like 10,000 collisions. So they'll smash a Volkswagen against a Volkswagen, and then they say, well, every time we find a front bumper that's bent at a 45-degree angle, we're going to say that's a Higgs boson, or that's a this, or this. We're going to give it a name. So they're naming a kind of bent fender, a fender that's bent a certain way. Yeah, we'll give that a name. And it's almost, I mean, maybe it's not quite that ridiculous, but it's pretty close in my opinion. They aren't doing much else than manufacturing a model made out of pieces that they aren't really parts of a car. They're parts of the parts. They're smashed together bits. They're steering wheels smashed into dashboards, and they're not real things. So yeah, I fundamentally doubt the existence of these things as real players. I don't think they are real players. The real player is the electron, the proton, the neutron. These are the durable parts of an atom. The rest of this shit is steering wheels, seat covers, trunks. They're just not, how to put it, they're not wheels, they're not engines, they're not bodies. They're pieces of those things. Yeah, well, the point is making durable things. And I'm just saying that, in my opinion, physics, to be part of the explanation or part of the model, the thing must have a durability. Like a photon, it's got to be able to travel across the universe for 15 billion years and not turn into a hippopotamus or something. I just don't think electrons are that complicated. So yeah, I don't think quarks are. I think they're just describing. They end up just describing the fact that you have clumps of energy that are transferred between electrons and protons, and those clumps of energy have a spin, and that's it. You know, they have a velocity in a direction. But I just don't think it's, I think the electron is a more stable thing than that. I guess that's what I'm saying. And I think it is, I think it's reasonable to suspect that electrons might have a complexity of their structure. So let's say, to define like 3 colors, you could say that there could be 3 different planes of orbit inside of an electron. So you have the blue one would be the tightest, the yellow would be the middle, and then the red would be going this way, I guess, and it'd be the widest orbit. So you'd have 3 orbits inside the electron that cover the 3 dimensions. And so you could say that the quark is one of those orbits. So the strange quark would be the red one, and the, you know, you could say the yellow size would be the whatever friendly quark, and then the smallest one would be the whatever happy quark, or whatever. They have these silly stupid names, something like that. So I guess I'm saying, yes, I do believe, I guess it's that there could be parts, but those parts can't exist independent. So it's like saying that you could take the Earth out of the sun, out of the solar system, and it would still be orbiting. It wouldn't. It needs the system to be what it was. Yeah, how come my icon disappeared? I mean, my video. Maybe somebody's coming into the room. I don't know, weird. I don't know if anybody can mute my video. Maybe they muted my video. Doesn't give me any icon indicating that happened. Huh, strange. Don't know what it means exactly. Don't know. Am I still here? I can ask that question. A mini cam icon. Strange. I don't have that loaded on this computer. Well, I guess that was somebody else's. So yeah, somehow I guess, I don't know. I don't know what it means. Very strange. Shouldn't be no obstacle to somebody joining the room. People have done it before. Oh, what's this comment box? This has got comments in it too. I really hate this. This never worked before. Huh. In them, why don't you do math values and quantitative method of verification of your model? Well, that's what I'm doing, you jackass. Didn't I just do some math? Didn't I just point out how you have to spread the velocity of the photon over the entire mass of the electron? Didn't I just do that? Who cares what you see? You draw insane pictograms. Oh, fuck you. I don't think they're anywhere close to being insane, you cunt. So let's see. How do I get rid of this asshole? Oh, he muted me. What a little cunt. Where's the, how come this chat doesn't allow me to block people? Strange. It's very strange. I can't mute him. I can't kill him. I can't annihilate him in some way. Let's see, I'll click on his name. I don't want to do that, but that doesn't do anything. How do I get rid of this fucking cunt? That is really strange. Okay, let's see. Guess I have to look into this. All right, so I can make that chat appear or disappear by clicking the button. Well, I guess since he left the room, I can't do anything. So I guess that's why I can't mute him now. Why can't I retroactively block the little fuck? It's another great feature, YouTube. Let's see if I can add a name to the block list. Let's see if that works. I'll grab his name. And let's see if I got a block list here somewhere. Invite people. That probably isn't going to work. I'll just look. No, can't do anything there. I hate to hit the settings button. It's probably some sort of disaster. All right, it's got that right. So it's got my camera identified properly. I don't know why it's not picking up my camera. Yeah, I don't know whether you still see me. Maybe I have to unclick me or click me. I don't know. No, it didn't work either. I don't know. Not working. I guess we have to just say it's not working. All right, so there's no features here. This is really stupid. They don't give you any ability to kill these fuckers. Yeah, that just sucks. All right, well, enough of that. I'll close that thing. But anyway, taking nootropics to boost your brain powers. Yeah, whatever. Not convinced any such mush does much. You know, everything you do always, it's that whole yin yang thing. And you end up, pull the cord one way, you end up pulling some other cord the wrong way. Yeah, really, YouTube just sucks. I mean, the funny thing is they're not even indexing my own videos, the Inmendum account videos, on the word Inmendum. And you're just like, come on. What the fuck? You can't get more of an Inmendum video than the Inmendum videos. But they do that every now and then. They just kind of, I guess I could put on some kind of no likey list. An Inmendum video, then so they just say, fuck you, can't play anymore. They do that every now and then. They just kind of, I guess life isn't a very good name. Life sucks. It's got a skanky cunt. Why does this mean if you type in quotes the word Inmendum into the search bar, right now there'll be no results as far as I know, because they're not indexing my recent videos. So especially for this week. So if you had changed the filter to this week and on the word in quotes Inmendum, you'll get nothing. Where you should get a list of all the videos that have Inmendum in the title or that were made by Inmendum. That's what usually shows up. But they're not showing up this week. Well, the what the fuck shows up from Saturday last week. I mean, none of this week's video shows up for me. I'm just saying. So, and I don't know whether you put the word in quotes or not. So if you don't put it in quotes, you get all kinds of rubbish. You get related videos and all kinds of stuff that has nothing to do with Inmendum. Well, the point is I have this account. I could try it from this account, theoretically. And this account is different than the other account, so I could definitely do that if I have to. I mean, you're really going to force me to do that, then I'll do it. But it seems kind of irritating. I mean, it seems even more irritating that why would there be a difference? If it's my own account, why should they be serving me different results? That's kind of cheating, isn't it? Oops, I didn't put the in part. Yep, just got to do that again. Let's see. Well, Mendham at least comes up with football teams and shit. The Great Mendham football team. Great Mendham football team. All right, let's see what you get. Yeah, well, they came up. Maybe they fixed it. Ugh. So yes, let's see. They got the 2 Anaconda videos. No what the fuck though. The what the fuck still isn't there. So they've taken that out. Oh, these are 9. That's 9 months ago. Let me put the filter on this week. See what happens. Yeah, there it is. Just crap about crap. Okay. Even this room shows up. DraftScience live now. That's funny. Yeah, nobody's making in-Mendham response videos anymore. I used to get, response videos at least from crazy people now and then, but I don't get nothing anymore. Anyway, at least that's resolved. It does work. Okay. Didn't work yesterday, that's all I'm saying. Alright, so that goes back, and I have to get back to this. Which room is this anyway? 814, yeah, that would be it. It shows up on Mendham today, yeah, which is funny, it does. Which is good, I'm glad they realize the 2 accounts are related. They have a common denominator. Today, yeah, we just. Alright, anyway, yeah, I don't have them linked. At least as far as I mean, obviously YouTube knows this shit, but they do have the different phone numbers and all that kind of crap. But oh, okay, so you don't get them. So yeah, so there. I guess it's variable. Well, the point is YouTube's never had a very good search system, but the search system has just gotten worse and worse. And it's like searching on Google, right? I mean, it's just you don't know what you're going to get. It depends on what things you've bought this week, what results are in the search, right? Isn't that disgusting? What I buy on eBay changes my Google results. I mean, that's terrible. Nobody's complaining about it, but I mean, I think that's just horrible that they're serving you a different internet than they're serving me based on what I buy. I mean, that's just terrible. Yeah, I know, but even if you remove the personalized search, I'm sure they're going to do this regional thing. So the point is that the default should be search the internet, not profile me, right? I'm just saying that you know the default should be the clean results, not the dirty results. But if you want to make excuses for Google, go ahead. I just think it's outrageous that a search engine would give people different results for the same keyword. I don't think there's any reason why the search engine should do that. Well, not storing cookies isn't really a great idea because, frankly, they're quite useful to the function of many websites. So, yeah, I don't see the big threat. You can sort of do that with Firefox anyway. You can just use a private window, and you're basically blocking everything. Yeah, well, whatever. Probably enough of this conversation. So anyway, I'm probably getting tired also, probably. And so I probably did enough good work here tonight. So I think I've gotten some good work done, and I will attempt to come up with some symbols that allow me to draw this more coherently. But it's all this conservation of everything except, well, it's even conservation of polarization. So some symbols. When you do convert polarization, you have to convert some other polarization somewhere else to do it. Left, right is turned into forward, back, but it's got to be moved from one dimension to another dimension, or it's it's conserved. You ever have dark visions? Well, I suppose. I don't know. There's all kinds of, horrible things that can happen anytime. So, Well, I'm just saying you can clear cookies anytime you want to with Firefox. Let's see, like landscape of burning embers. I don't know what that means exactly, but whatever. No, too poetic for me. Anyway, so till the next time and such, and I have to get some live people to play along here once in a while. It's been a little scarce lately, and it's disappointing, but it doesn't stop me in my performance of my task, which is good. Yeah, so I'm not deterred by all of these obstacles. I just keep plugging away. I'm the good little engine that could ask, which is good. Or we'll keep trying anyway. Maybe I can't. Let me keep trying. Hey, look at that. My video came back for a minute when the life guy popped in, but it's gone again. I guess the life guy doesn't have live technology. Maybe he's doing some trolly thing. I don't know. It's not a very good name, like I say, for me. It's not a good name. Oh, life expectancy. Maybe that's who it is. Yeah, it keeps popping in and out. I blocked him, didn't I, or something? I thought I did. But whatever. Doesn't really matter. Yeah, life expectancy 73. I think I blocked him. I think so. So maybe that's why he can't get in the room. So I blocked him. Maybe. Sounds like a reasonable surmise. But I don't know. Doesn't really matter. All right, anyway, so let's see what this last thing is here. Deep interelastic shattering is the name given to a process used to probe the insides of hadrons. Whatever, particularly baryons and such as protons and neutrons, using electrons, muons, and neutrinos. Well, I don't even know if the neutrinos are a real thing, frankly. And these whole anti-particle thing, I think that's all crap. This whole and not baryonic matter thing is just idiotic, I think. So much of this is crashed particles, exactly. More just Volkswagen residue. This whole and not baryonic matter thing is just idiotic, I think. So much of this is crashed, in other words. Hey, look at that. Somebody who has a horrible icon. Yeah, I don't know what that was. Supersymmetry. I'm not sure what supersymmetry is, but I can't recall exactly. But it's just super stupid. It's, it's based on this stupid notion that things are in two places at once or some other crap. No, that's true. Spooky action at a distance. Einstein was right. There's no such thing. It's just voodoo. And nonsense. And well, there's no such thing as multiple universes that are in any way communicating with each other. It's just silly. They're not parallel. They're not stacked on top of each other. They're not intertwined or intertangled. They're in any other way connected. It's just a pile of shit. Preposterous shit, made up shit. It's just a God theory. It's just kind of funny. Like, we got free of God and killed him and all that stuff, and then physics is trying to remake him in their imagination. They're just saying, well, I can imagine some kind of bizarre explanation. Let's come up with the most bizarre explanation that can be bent to fit the facts. Physics, and that's all they're doing. So they're doing the same thing as the primitive man says, ooh, thunder, what could possibly be making that? Instead of saying something like, well, when I clap my hands, it makes a noise. Maybe there's something up there kind of banging into each other and making a noise. No, instead of that, they come up with, Zeus farting or something. So, yeah, it's just very bad. Yeah, well, whatever. I'm just I can't really have a lucid conversation about baryons and fermions and doumions and punyions and zoomions and all this crap, because it's all made out of force. And so that's really all you're talking about, is a force of a certain density interacts with another force of a certain density, and that's it. There's nothing else going on. It's all made out of... there's only one particle, so the whole definition of particle is fucked up. An electron isn't a particle, it's a collection of particles. An electron is like a hurricane. You can have little storms inside of it, but it's a hurricane. Doumions, wow. Yeah. Fluckmions, suckmions. WWE, I don't even know what that is, but I don't think so. I don't like WW things. Yeah, no. It's usually stupid and moronic, like the internet itself. All right, so anyway, I'm leaving. So you all can stay, but I'm going. So till the next time and such, so forth and whatnot. Leaving the call. Shall I stop the broadcast or leave the call? Well, I guess I better stop it, because if I leave it, then you'll still be here. And there'll be no point in that, because none of you were talking very much. Another voice. Yes, good night. Yeah, thank you for those who do attempt participation in some meaningful and useful way. Thank you. Oh, look at that life guy's trying again. Look at that. Isn't that cute? Yeah, thank you for those who do participation in some meaningful. Keep trying, asshole. I don't know exactly what you're doing. I guess I could just eject you. Yeah, I guess I could do that. Whatever. Arrange that you're permanently blocked from participation in the human experiment. Anyway, till next time.